Okay, let me welcome all to the first AN Mitra lecture. I have already written about Professor Mitra several times. The first one was in 2014 when I wrote for the Current Science. Next one was in 2023 when he died. I wrote for the Hindu journal and the Current Science. I referred to the ideas of Professor Mitra on religion. Even though in the year 1975, Professor Mitra and I were invited by George Sudarshan to come and attend the meeting of Mahesh Yogi. Anyway, let me now use some of his own writings to talk about Professor Mitra's talk, views on religion. Mitra likes to begin with Cartesian partition. This is the Cartes who started the Cartesian orthogonal coordinates, which are the XYZ coordinates, and as different from R theta phi coordinates. And René Descartes was actually a philosopher as well as a scientist, but he laid down a partition, which is often called the Cartesian partition. And this partition was that religion should not be part of science. Probably he did this to make faster progress in science because the discussion of religion can go on and on and on and goes off all the time. So this would help the science. Thus, in spite of the views of Kepler and Newton, this partition somehow took effect. I'm saying this because Newton was a great believer in God and he believed all natural laws were due to God. And Kepler also thought there was a natural order which brings its loss to science. J.N. Mitra quotes G. Holton to say that the theory versus experimental proof is the proof of the scientific method, is the basis of the scientific method. And from almost 1660 to 1900, this partition worked very well. So for almost 250 years, it worked very well. But unfortunately, when the 20th century began, there was a big problem because the relativity came in, the arrival of relativity, which made time relative, and quantum mechanics, which made causality statistical, diluted determinism, and changed the whole picture. And by 1930, everything was total chaos. This is because quantum mechanics brought in participatory physics, and the effect of H cross finite is very, very important. Time in relativity, time is relative. It is important if a velocity is comparable to that of light. In quantum mechanics, photon and later electron are both found to be particles, localized, as well as waves like Atma and Paramatma in religion. Causality and determinism both become statistical. Individual event cannot be predicted. Einstein thought quantum mechanics is incomplete. Bohr, with his complementarity, argued that one can do no better. Unfortunately, we still have no agreement on what is really a complete theory of quantum mechanics. F. Capra compared the universal and self-interaction in quantum mechanics to unity in the universe experienced by mystics. On that basis, he thought bootstrap theory should be correct. Unfortunately, he turned out to be wrong because it is quark model as fundamental particle, which came into prominence, even though the quarks cannot be observed individually. Maybe instead of mysticism in science, we need science in social science. And in our lives, we really have a lot of emotions. Our lives are full of emotions, love, compassion, joy, ecstasy. And so it is really the other way around. We need science to come into scientific temper or mysticism. To discuss this, I must go back, I must go to a philosopher called Ronald Searle from University of California, Berkeley, who gives what I thought was a nice separation of natural science from social science. He says natural or God-made laws are in natural science, and man-made laws like marriage, justice, income tax are in social science. Scientific temper which applies rationality and logic to life, then becomes a social science. It has huge error bars, no agreed axioms, and requires immense tolerance or alternative views. Now, Professor Mitra has written a number of articles on
Professor Panchapakesan, I really apologize
and religion.
Professor Panchapakesan, I apologize to interrupt you. Could you also kindly guide us? What slide number are we at right now?
Oh, you want me to go back? Okay.
No, I assume we are now on slide number 2. We were waiting for you to say next.
Okay, one moment.
Just to correlate what you're saying with what is visible.
Maybe I can end the show and start again.
No, you don't have to. Just let us know what slide number should we be showing.
No, do you want to show my picture also in the screen?
No, it is visible. It is visible. Just let us know the slide number.
So should I go on to the next slide or the previous slide?
Okay, what slide number are you currently at on your screen?
I am trying to have the earlier one.
Oh,
yeah, this one. This is the one that I want to have.
Okay, great. So when you want to go to the next, kindly let us know that you'd like to go to the next, and then we'll immediately go next.
Pardon, I didn't get what you said.
So when you are done with the slide and you'd want to go to the next slide, please let us know so that we can click next and go to the next slide.
Okay. In this slide, I have listed the references of Professor Mitra. As you can see, the references started quite early. In the year 1986, that is reference number 2, he wrote an article in Pramana on duality in physical sciences and beyond. This was his first entry, I think, into print of his views on religion. And then in 1990, he wrote for Physics News something on parameters of physics perspectives, principles, and postulates. This was actually a talk he gave in Delhi University's Department of Education, where my wife Nargis, who was also a student of Professor Mitra at one time, had invited him to give this talk. And then he wrote a much bigger article in 1993. This was in Current Science. And then he wrote a foreword to the book by R.S. Kaushal. The book was called The Philosophy of Vedanta, A Modern Scientific Perspective. And I have really quoted from this book about the partition and other things he talks about. But apart from all this, I must also, while I'm giving references to Professor Mitra, should talk about a very, very good book, which Professor Mitra edited and published when he was 80 years old in the year 2009. It is called India in the World of Physics Then and Now. It is published by Pearson Education, and it is part of a series of books called History of Science, Philosophy, and Culture in Indian Civilization. It has got very good values, very good reviews by experts. It has a very good review by Professor T.V. Ramakrishnan also on condensed matter physics. And it begins with a remarkable photo in the beginning by Jean-Jacques and Gargi Delamont of the areas of physics covered after the independence in India. Gargi quotes also a couplet by Tagore, which is very interesting. In Bengali, it says, Simar Majhe Asim Tumi Bajao Apan Sur. In English, the translation is, amidst the finite, the infinite you, play your own tune. And so I would you see, this book is fantastic, but I find it is only in library and hardly anybody refers to. Maybe some people should take parts of it and write about it in Wikipedia or something like that. Yeah, I finished with this slide now.
So we're now on the slide which reads relativity and Q mechanics in 20th century.
So should I press something or you do something?
Is this the right slide? This is the one that you'd like to be at?
Shall I go to the next one?
No, Professor Panchapakesan, the slide that we are currently at reads as the header, relativity and Q mechanics in 20th century. Are we on the right slide?
Shall I go to the next slide and talk? That may be simpler, huh?
Do you want us to go to the next slide?
Okay. The next part of my talk is really about black hole QNM, quasi-normal modes. And before I go to this, I must say that I heard something which many of you must also have heard, that if you make a better mousetrap, the whole world will make a line to your house. So this work of ours is also a bit like that, improves something and gives a calculational tool. Let me first give a brief introduction to black holes. Black holes came into astrophysics in 1931 when Chandrasekhar showed that white dwarfs have an upper limit in mass. Later on, it turned out to be true for neutron stars also. So if a star has a much greater mass, it cannot become a neutron star or a white dwarf. So it must become something else, which we now know are black holes. But unfortunately, nobody believed in black holes, especially Eddington, who was Chandrasekhar's supervisor. And because of that, nobody did much work on that. But long period later, Wheeler and his group in Princeton and groups in Soviet Union did a lot of work on this. And in 1972, Misner, Thorne, and Wheeler summarized the status of the subject in the book Gravitation. By that time, quasars were identified as black holes also. From India, C.V. Vishweshwara was the first person to work in black holes, and he did some very remarkable work. He proved the stability of the black holes in 1970. He also calculated the quasi-normal modes of black holes, though he didn't call them quasi-normal modes at that time. These are the typical signals observed in gravitational waves when they are observed in 2016, much later. Vishu died a year later, so he really couldn't enjoy his glory of being the first one to give this particular signal. Chandra came back to black holes in 1960s. As usual, he ended up by writing a book on mathematical theory of black holes in 1983. Now, stability in black holes and elsewhere is studied by perturbing the black hole metric and seeing if the added signal is damped and dies out, emitting what are called quasi-normal modes. Solving the perturbed equations by separating the variables is an arduous mathematical job. In 1971, maybe I'll come back to sorry. Yeah, in 1971, at Delhi University, Professor S.N. Biswas, who was also a towering figure in the Delhi University, and four other very talented youngsters wrote a paper in the Physical Review in 1971. The collaborators were Kamal Datta, who got his PhD from Brandeis, R.P. Saxena, who was the first student of Professor Mitra and wrote a big fat thesis on meson renormalization. And then Pramod Kaur Srivastava, absolutely brilliant person, who, along with Vijay Verma, both moved into science education later on and were supporters or founders of the Hoshangabad science teaching program. These people got together and wrote this paper, which really shows it is called the Hill determinant method. And a general differential equation, when expressed as an infinite sum of constant coefficient, gives a recurrence relations. The boundary conditions satisfied determine a three-time recurrence relation. Hill determinant can be written down once the recurrence relation between constants are known. The vanishing of the Hill determinant helps in finding the eigenvalues of the solutions, which are the quasi-normal modes. We can call this the Delhi University Hill determinant method if you want. Till an improvement is found, this can serve as the method for the moment. But I was surprised to find in the program, we have another talk by Jatu Kunz from Germany, who is talking about this method again for a special class of metrics. That will come tomorrow in the afternoon. This was Bhavani's PhD thesis. And Bhavani Majumdar and I, in Physical Review in 1989, applied this method to QNM. It is said that people will queue up in front of your house if you build a better mousetrap. So that paper now has 50 citations. It's not a very large number, but very surprising to us. The cited papers all use this method successfully. Well, I come to the end of my talk. Oh, is it 20 minutes or 25 minutes? 25 minutes I'm given. Okay, then I can talk a little bit more. I've sent a copy of my current science article on scientific temper and education separately, and this may help in clarifying issues. Yeah, this is since I have time, I'll talk a little bit more. This is a quote by Alfred North Whitehead on religion. It is a very unusual quote. It says, religion is the vision of something which stands beyond, behind, and within the passing flux of immediate things, something which is real and yet waiting to be realized, something which is a remote possibility and yet the greatest of present facts, something that gives meaning to all that passes and yet eludes apprehension, something whose possession is the final good and yet beyond all reach, something which is the ultimate ideal and a hopeless quest. It seems to me all this is a nice way of saying we do not know what religion is in a very fundamental sense. And my ideas, of course, are on the other paper which I sent to you. Yeah, and religion, you see, depends really, as Fritjof Capra mentions, on mysticism and some kind of a revelation. And you'll be amazed to know, Mitra asked this question, does religion lead to truth? He also asked the question, will science also lead to truth? Einstein described ecstatic revelations. He has already had one in a article, A Cosmic Religious Feeling. And he believed that values which are crucial for our life are given by people with revelations and not by individual people. Hindus, of course, call this cosmic revelation religious feeling. When Feynman was asked by Fred Hoyle whether he has had any revelation, he said, a few minutes of ecstasy means nothing to me. Whereas Hindus believe even if it takes several births, it is good to have ecstasy. The first person to bring religion and Wigner together, which unfortunately wasn't successful, was by Wigner. In 1960s, Wigner wrote that the collapse of the wave function take place is the consciousness of the person. But fortunately or unfortunately, in the 90s, he withdrew this because by that time, people had discovered that decoherence takes place much, much before it goes into the consciousness. So maybe because of that, you can't really invoke this. But as I said, we don't really know much about all these even now. Yeah. Okay, thank you very much.
Thank you, Professor Sir. So now we have 5 minutes for discussion and feedback, please, from the audience.
May I unshare the file now? Can I stop sharing the file?
Yes, yes, please. Yes, you can raise.
There are no questions, is it?
But still, we have few minutes. Let us wait, sir.
Okay,
Professor Kausal is raising his hand.
Okay, please, Professor Kausal, please.
Kaushal is there. Kaushal is raising that.
Yeah,
Kaushal.
please, I have little query. Professor Panchapakesan, and very good summary of the Professor Mitra's interest on philosophy and science. You see, there are two words used. I still don't understand after so many years. One is Cartesian partisan. Religion and science, they lie in the he calls that Cartesian partisan. Second, what is the contingent plane in the context of work of Holton? Could you please elaborate the meaning of these two?
Pardon? I didn't quite catch the question. Huh?
See, he talks of Cartesian partition.
Yeah.
With regard to religion and science. Are they
Yeah.
really Cartesian or they have some overlapping domain? Second thing, he talks of the contingent plane in the context of Holton's work.
Right, that's right. Quite right. Quite right. Absolutely
States.
right. Yeah.
I have not yet understood this after so many years.
Yeah. Yeah. You see, the criteria for separating the two things, religion and science, is the scientific method. And he calls this the contingent plane, which is the two-dimensional plane of theory and the verification of experiments. But that is not really very convenient, because when you go from science to religion, you're really going from rationality to a whole lot of emotions. Without emotions, religion doesn't make any sense at all, nor does social science make any sense. So you have to, I would prefer the method of Ronald Searle, in which he separates the two, one as man-made, rather God-made laws, and other as man-made laws. That
Man-made.
probably is a much better one.
Just another query I can have. Nimai Singh, will you permit
Yes,
me
please.
to ask one more?
Yes, yes, we have time. We have
Yeah.
time. We have time.
See this,
No,
with
I
regard
didn't.
to absolute reality, with
What
regard
would be
to
reality?
absolute reality, we have subjective reality from in the top-down manner, objective reality in a bottom-up approach, right? So absolute reality is a combination of the both, right? So in this respect, what I hear these days in the West, they talk of spirituality but not religion.
Okay, okay.
Yeah.
Yeah,
So there's a
yeah,
move in the society. They want to
yeah.
become spiritual but not religious. What are your comments on this observation?
Yeah, no, that is possible. But you see, as Prof. Capra describes in his book at great length, the whole point about realizing the truth is it gives you a tremendous feeling of Brahmananda. And you see, reality gets totally merged in that. All kinds of reality. There's a whole unity. The unity is much more important than anything else. So unity in Capra uses the fact that quantum mechanics brings much more of unity than earlier science used to do. I don't know how far that is true, but anyway, thank you.
Yeah, yeah. I think we have time. We have finished our budget. So let us thank our professor in Panchapakesan for his good delivery. And this talk require more than 1 hour. We can have in future sir again.
Yeah.
Okay, thank you.
Yeah, yeah.
So next, and let's pass to the next speaker.